weekend? Anybody watching the basketball? Neither did I. The first time in my life.
Watch this out there.
Yeah. So today we're going to finish, I think we got to this point like what seems like eons ago. We were talking about recurrent selection or population improvement. We talked about intra-population recurrent selection and the various ways that that's done. So the other basic form of that is interpopulation recurrent selection. And so this is a method, and I think I mentioned this before in that one session, that this is used to simultaneously improve two populations, two heterotic pools, for the degree of heterosis that you get. So it's kind of like a way of, in essence, gradually maximizing the genetic differences that you have between two pools of individuals. And I think as you saw from that Longan wheat hybrid paper we discussed a couple weeks ago, this is one of the things that would need to be done in any crop where they're trying to improve the level of heterosis that they see in the breeding program. So in this, then the basis of the evaluation is not, as we talked about with phenotypic recurrent selection or family-based methods, it's not looking at evaluating an individual based on crossing that individual to other individuals in the population. The materials that are crossed are from this other population, and so that's really the basis of the evaluation. So there's three different ways that this is done, and Bernardo shows this diagram right here, and I'll just go through it really quick. What he calls reciprocal recurrent selection, which I don't know why he does this, but for me that's just always been just kind of like a general name for the method, but then there's different ways that you do it. But he says that reciprocal recurrent selection is based on evaluation of half-SIB families. So, and all this stuff, the terminology gets a little confusing. And then based on full SIBs, he calls in reciprocal full SIB selection. Why not call the other one reciprocal half-SIB selection? I don't know. But these are the three different kinds that he shows. So you have two different populations. This is, again, based on half-SIBs. Population A and population B. And this 0 here means the cycle. So these are the populations in cycle 0. You do some stuff, and then you get supposedly improved populations that then are in cycle 1. So in this case, in population 1, half-SIB families are developed, as we talked about the other day, by crossing individuals in that population, right, to some collection of pollen, to some group of individuals that are from the other population. And you do this on both sides. You evaluate those half-SIB families in yield trials, depending on how much seed you can get and so forth. And then at the same time, you're self-pollinating those individuals. Remember we talked about that? Remember we talked about that in the last session before break, that the seed from the individuals that are evaluated is not used to recombine for the next cycle. So in this case, all those individuals that are crossed, they're also they're self-pollinated to then the superior ones then in total represent the cycle for the next cycle of recurrent selection. So that's based on half-SIBs, based on full SIBs. This is where pairs of individuals are evaluated. A certain individual from this population is crossed with a certain individual from this population to create a full SIB family. And the seed is harvested from those individuals, tested in yield trials. And so really it's the same format. It's just what is the pollen parent that's used to create that family of individuals. So then Bernardo also talks about use of this with an inbred tester. So in this case, So they're half-sibs. The pollen parent for each of those half-sib families is a collection of individuals from that population. Here, it's specific individuals from that other population, that other heterotic pool. And then here, it's just some line. It's perhaps some line that's currently being used as a parent of a hybrid. And so terminology may be a little bit different. It's a test cross that's used, but still the self-pollinated individuals then are recombined to form the next cycle. So Bernardo does talk about this in the context that this is a more logical way where you're in a program that's developing hybrid cultivars, because any of these individuals could be a hybrid combination, right? That could be the parents of a particular hybrid that could be released to farmers. One other thing about this reciprocal full sib selection, so to be able to, on the same plant, cross that individual and then also self it. So this method in particular is really well suited to something like maize. With maize, we have prolificacy, where you have one main stem, and then maybe sometimes you'll have like another second one with a little small head, ear. So like in wheat, we call those tillers, and you could do this in wheat, but you'd have to emasculate them, which would be difficult. But these procedures, in particular, this one is very well suited to something like maize that has that reproductive, flexibility. Okay, so again, that's just a kind of a general look at reciprocal recurrent selection. So if you recall the diagram for Bernardo that I presented weeks and weeks ago about the different methods, you have heterosis and not, can you produce seed or not, can you tolerate inbreeding or not. This is another general class of cultivars which are synthetics. And the breeding systems for these are really kind of strange in a sense, but really only in the context of how the cultivar is constituted. I'll get to that in a minute. So by definition, a synthetic cultivar is an advanced generation of an open pollinated, so it's like an open pollinated variety, but it's based on individuals. There could be strains or clones. I think this is the definition out of Fair's textbook, that these individuals have some identity. So you identify some good individuals in a population based on some things that we'll talk about, and then you use those superior individuals to intercross them, random mate them as much as you possibly can, and then that is the variety. So it's different from an open pollinated cultivar, which I'll talk about in a minute, where the population itself becomes the variety. I'll make that hopefully a little bit clearer here in a moment. Yeah?
This sounds different than the synthetic hexaploid wheat.
Oh, yeah.
Okay, so it's the same term in
Yeah.
different meanings.
Yeah, this is like, apples and kumquats. So it's very, very different, yeah. So the term synthetic just refers to, I guess, though, in that same vein, the term synthetic just means that the population that becomes the variety is synthesized in a very specific manner, which is different from how an open pollinated variety is constituted. The open pollinated variety is a population of individuals. This is too, right? But let me move on. Maybe it'll be a little clearer. So these are open pollinated varieties, and they're similar yet different. So in this case, plants within this population that we call this synthetic variety, the plants are highly heterozygous, and the plants within the population, there's a lot of heterogeneity among the plants. So alfalfa is one predominant, one very common crop, which the breeding methods follow these sorts of schemes, and those are just really mixed populations of individuals. It's always seemed really odd to me how they categorize it. This population is 40% resistant to this insect and 30% resistant to that insect. And so they're highly mixed populations of individuals. They're different, though, from regular open pollinated cultivars in that the parents of that synthetic variety are reproducible. They're clones or inbreds. And thus, to generate the seed of the variety, you can always go back to those same individuals. And that's not the case for a regular open pollinated population that we call an open pollinated cultivar. These, an open pollinated cultivar, population can change due to the environment, due to some sort of natural selection. And I guess unless you were to like save seed in a freezer somewhere, you can't go back and reconstitute that population. That is a variety, but in the case of synthetics, you can. So this is still probably a little confusing. I'll hopefully make this a little clearer. So historically, some crops that are commonly, it feels like you got the heat working. So it feels warmer now.
Right.
So historically, some of the crops that are commonly bred today as hybrids, maize, for an example,